goes when the weather froze. Just put away the leathers and put ice on the gold. Chilly with enough bail money to free a big Willie. High stakes, I got more at stake.
Okay, so cycloid, I think of like bicycle, tricycle kind of thing, so like a wheel, right? So this is actually going to be a curve that is traced by, this is kind of a cool one. It's a little bit complicated, but it's cool nonetheless. So it's traced by a point on the circumference of a circle as it rolls away. Okay, so this is what it looks like. So let's say we have a y and an x here. So this is x and that's y. Alright, so let's say we have a circle. This is going to be interesting. Okay, so here's a circle, right? Here's the center. And let's pick the point that is right down here, sitting on the bottom, okay? And we're going to roll it this way, okay? So it's going to roll over itself. So it'll start going like this, okay? And once it moves here, that means that this point down here has actually rolled up a bit. So let's say it's here now, okay? And this is for the second circle. So this is, okay, hold on. So this is the first position we're looking at, right there, right above it. This is the second position, and the dot is right here on the left, okay? And then, let's say we get to here, right? So then we're over here as time goes along. This is position 3 we're going to look at. And now, that point has rolled all the way to the top, okay? And then we'll keep going, something like this. Hold on here. Let's say we're here now. And now the point is right over here. It's going on its way down, right? It's still rolling, okay? Still rolling. And then eventually it'll come back down, maybe right here or so. Okay, almost done here. So this is just one cycle of our cycloid. Okay, so this is position 4 and 5. Okay, so as we see, if we're tracking this point along as time goes along, it'll kind of make an arc like this, okay? And then, as we continue rolling it, it'll go again, and if we extend the x-axis out, it'll make another path, just like the one that we made right now, okay? And it'll keep going. It kind of looks like a ball bouncing, but instead, the path looks like a ball bouncing, but it's actually as we're rolling this wheel along, okay? We're just following a point, okay? So that's the general kind of like concept behind what is a cycloid. And now let's see, how are we going to parametrize it? So let's look at the unit circle first, okay? So we're going to look at kind of like a unit wheel, I guess you could say. So here's a graph. So we have our y and our x. So let's say, I'll kind of blow it up so we can get a good view of it. So here's a circle, all right? So let's say this is the unit circle, right? So we have radius of 1, okay? So radius here, this height is a 1, all right? And then let's say we're tracking this point right here. Okay, so this is point P, the one that we're following. So right now it's traveled this far, and it's going to continue on and make its arc, which is not going to go that high because it will only go as high as the circle can go. So it'll go something like that, okay? So it's on the way. It's rolling this way. Now let's see, like, what point is this P at? Where, like, what X and Y coordinates? So how are we going to determine that? So basically, the arc that you see, the distance that it has rolled, kind of, I guess you could consider it, that is going to be, it's like the angle right here. So we'll call this T. The angle T, that's how much it's rolled away from the origin. Because remember, it started, this circle started right here, and our point P was down here, okay? So in the beginning, it had an initial angle from the ground of 0. But now it has an angle of T, okay? And this arc happens to be the length of T, okay? And that is because we have the radius of 1, okay? Right now, we're just dealing with the unit circle. Alright, so T is the length of this arc here, and that's actually also the amount of distance, if you were to like straighten out that bold arc right here that we've already traveled, the one that I'm trying to make bold here. Yeah, so if we straighten that out, we would actually get this length right here, the x coordinate, okay? So that's going to be our t, all right? And now what we're going to do is, so what actually happened, so let's say it moved this far, right? I'm going to draw a little arrow. So it traversed t distance in the x direction, but now our p, our point P is not there, right? It's not in line with t. It's actually back a little bit. But how do we find how much it went back? So I'm going to blow up this circle here. So let's say that was really bad. Okay, hold on. So let's say, looks like this. Here's point P. That's what we're looking at, and here's the center of our circle. Okay. So this is 1. We already decided the radius is 1 because it's a unit circle. Okay. And if we make a little triangle here, so here's point P. This is the x-axis. Okay. And if we make a triangle by cutting across, okay, then we see that this angle, we already decided that was going to be named T, okay, and then this across from it, this distance is how much, so here's point T on the x-axis, this is where we're looking, point T, not the angle, but point T, and so this is how much, this length here is how much P is set back from this T, alright, so on our x, for our x coordinate, we have T so far, but we're going to subtract something from it because it's actually back a ways. Alright, so we're going to subtract whatever this length here is. And we can find that from our triangle because we know that the radius is 1. So the point, this length here from the center to P, it has to be 1. And then we see that, so that's our hypotenuse for our triangle. So I'll make the triangle in bold. Okay, so I'm going to bold that out here. So here's our triangle, right? And the length that we want to know, want to subtract away from T, is actually going to be T, or sine of T. Okay, so 1, our radius, sine of T. And 1 here is functioning as the hypotenuse, okay, of our triangle. Okay, so this is the parameterization for x, given that we have a unit circle. Now let's work on the y. So y, that one's going to be, so our, let's see what we have here. So we have our height is always going to be 1, or, it's going to be 1 because the length of our unit circle, the length of the radius of our unit circle is just going to be 1. And then, but we're also going to have to subtract away this much here. Okay, so we're assuming we're gonna travel up all the way to 1, and if it's not there, then it'll fall short a little bit, right? So here so this is 1, and then the down arrow means how far is P below that height of 1. Okay, so how far is this distance? And you can get that again from our triangle by taking the hypotenuse, which is 1, and then multiplying it times the cosine of T, because it's right next to that angle right there, right? Okay, so what we've come to is a conclusion of what our x and y look like based on T when we have a unit circle. So they look like this, okay, 1 minus cosine T. And again, this is for a cycloid. So the graph created by tracing the path of a point on a circle on a wheel as it rolls away. Okay, so this is what we have so far, and this is for a unit circle. So I'll stress that, unit circle. This is not for all circles that make a cycloid, but on the next slide I'll show you what a pretty easy trick you can do to find the general parameterizations for a cycloid. So for general circle of radius r, okay, capital R. So what our parametric equations are going to look like are x of t is going to equal r times whatever it was for the unit circle. So that was t minus sine of t. So this is r times t minus r sine of t. Or sine of t, yeah. And y of t is going to be the same exact thing. We're just going to multiply r times whatever it was before for the unit circle. So that's 1 minus cosine t. So this is going to end up being r minus r cosine t. Okay, so these are our general parametric equations for a cycloid. Cycloid created by a general circle of radius r. Okay, one final concept I'd like to cover, and this is of, let's see, what are we going to call it? So I'm going to call it the c prime of t, or this is like the first derivative of our parametrization. So this is the first derivative, there's an I, of our, and I'll call it c of t of our parametrization. Okay? So for this, let's say we have a curve. Okay, so here's curve c of t. This is c of t. All right, and let's say at a certain point, I want to find the slope of the tangent line, because us mathematicians, we love finding the slopes of tangent lines and everything to do with tangent lines, right? Because they measure how much something is changing at a given time. So let's say this point is x of t, y of t. Okay, so that's where we're at. That's this point, the one that we want to find the tangent line at. Okay, and to find this slope, what it is, so just in general, slope is your rise over your run, right? We all learned this in Algebra 2 at least, right? And so what this is going to be is actually like our change in y. So we want to know the change in y. How much has y changed? So here's our y prime of t. Okay, so that means how much has y changed, or you can also write it as dy dt. So how much has y changed with respect to time. And then going across here, this is our run. This is called x prime of t, also known as dx dt. How much has x changed with with respect to t. All right. So this is going to be the same as y prime of t. That's our rise over our run x prime of t. Okay. You can also write it as the following: slope equals dy dt all over dx dt, and see how we can multiply by the reciprocal on the bottom there. So if we flip it up, we have dt over dx, and the dt's kind of cancel, and they become dy dx. So how much is y changing with respect to x? Okay, and this is also given that x prime of t is not equal to 0. And that goes for dx dt as well. So the change in x cannot equal 0, because then we have a straight up and down tangent line which is undefined. Okay? So that does it for this video. I hope that helped a little bit on parametrizations in general, and I'll talk to you in the homework video if you watch.
Make this whole world believers, huh? Admire raiment, screaming. All us blacks got is sports and entertainment. Until we even leaving, as long as I'm breathing, can't knock the way.